In this video, I'll give you some basic definitions for linear equations and a general strategy on how to solve those equations. Let's start with some definitions. In general, an equation is a statement that two expressions are equal. A solution is the value or a value of a variable that makes an equation true. A linear equation is the equation that can be written in the following form: ax plus b equals 0. In this equation, a and b can be any real numbers. X is the variable. But this is just one form of a linear equation. Any linear equation can be reduced down to this form, but we are going to see that linear equations don't necessarily start out in this form to begin with. It's also important to note that here the coefficient a can't be 0 because that would make the variable disappear. All right, so let me give you a general strategy for solving linear equations, but do realize that these are just general strategies, that there are ways to kind of play around with the order depending on what kind of equation you have. So the first thing you want to do is try to simplify each side of the equation using either the distributive property and combining like terms wherever possible. Next, you'll use the addition principle, which means you're adding or subtracting the same term on both sides of the equation. And you're doing that to try to isolate the term that contains the variable on one side of the equation. So you'll try to get that variable on one side and get all the other terms on the other side. Then we usually use the multiplication principle, which means you're multiplying or dividing by the same non-zero number on both sides in order to make the coefficient of the variable 1. Then you could check your solution. Linear equations are nice because you could always check your solution. That's an optional step, but it's something that you could always do. And again, please note that sometimes we do some extra things or we change things around depending on the equation that we have. All right, so let's start out with these two examples. For each example, you see that there are parentheses. In the first example, you have sets of parentheses on both sides. In the second example, we have nested parentheses. So you have parentheses within another set of parentheses. All right, we are going to begin with example 1, which I have written on the page here. So we're looking at the left-hand and the right-hand side of the equation. We see parentheses, so we could use the distributive property to open up those parentheses. So I'm going to, on this side, multiply by 8, which gives me 8q plus 8 minus 5. On the other side, distributing the 3 to have 6q minus 12, and then minus 1. So I use the distributive property to open up those parentheses. Now I can combine like terms that are on the same side of the equation to try to just clean it up a little bit. So I have like terms here, the 8 minus 5, which is 3. So that side is 8q plus 3. On the other side, I have a negative 12 and a negative 1. When those are combined, I have negative 13. 6q minus 13. So all I did there was just simplify each side, each expression. Now I can use the addition principle to try to isolate the term with the variable on one side and the constant terms on the other. It doesn't matter if you put the variable on the left or the right-hand side. It's just really up to you. So I actually have a choice of 4 terms that I can add or subtract. It doesn't matter which one you pick. I'm going to decide to subtract 6q from both sides of the equation. When I am combining like terms, I'm adding the coefficients. So 8 plus negative 6, or 8 minus 6 is 2. Bring down the variable q. Plus 3 is the constant that's on that side. Always bring down your equal sign. 6q minus 6q is 0, so that cancels that term out. And here I have negative 13. Since I have the variable now on the left-hand side, I need to get the constant on the right. So I'll subtract 3. So it gives me 2q equals negative 16. So finally, I have 2q, but I want to know what 1q is equal to. So I can divide by that coefficient 2. Do the same thing on the other side. and that gives me q is equal to negative 8. So the solution for this equation is negative 8. I can check that solution by substituting that value into the original equation for q. So 8 parentheses, negative 8 plus 1 minus 5 equals 3 parentheses 2 times negative 8, I'm squeezing this in, minus 4 minus 1. Just fit that in there. All right, so I'm just going to simplify each side using order of operations. Negative 8 plus 1 is negative 7. So this is 8 times negative 7 minus 5. On the other side, I'll do one operation, and here I have multiplication. So 3 times negative 16 minus 4 minus 1. And then continuing, doing one operation on each side. So that's negative 56 minus 5 equals 3 times negative 20 minus 1. On the left-hand side, I have negative 61. On the right, 3 times negative 20 is negative 60 minus 1. And then do one last step on that right-hand side to show that I have the same value on both sides of the equation. Negative 61 equals negative 61. If you have the same quantity, your equation is correct, is true, which means that negative 8 is the correct solution. All right, moving on to the second equation. In this equation, see that we have nested parentheses, so I have parentheses within another set of parentheses. Generally, the strategy would be to work your way out. So we'll start within the brackets, simplify within those, and then move outside. Again, that's just a recommended step. There are certainly other ways that you could go ahead and proceed with that example. All right, so here we have the problem right now. Once again, I'm going to work from the innermost set of parentheses. So I'm distributing the negative 2 to the 7y minus 1. Everything else is going to stay the same. So I'll write that part first. Negative 2 times 7y is negative 14y. And then negative 2 times negative 1 is positive 2. That opens up this set of parentheses, but everything else is still there. So I have 4 here, bracket, and 6. On the other side of the equation, I can distribute the 8 to both sides of the equation. 8 times 13 is 104. 8 times negative 8y is negative 64y. I still have the brackets on this side. I can simplify within them first before I distribute, or you could distribute now, it doesn't matter. But I'm going to just combine the 4 and the 2. So 6 times 6 minus 14y equals 104 minus 64y. Now we'll go ahead and distribute the 6. 6 times 6 is 36. 6 times negative 14 is negative 84, so that's negative 84y equals 104 minus 64y. Now I can go ahead and combine, well, I don't have any more like terms to combine, but I could try to isolate the y on one side of the equation. Again, I have really 4 terms that I can decide to add or subtract. I am going to add 84y to both sides. Even if you picked another term to add or subtract here, you'll still end up with the same solution. So those are additive inverses, they cancel out. 36 equals 104 plus 20y. Now since I have the y's on the right hand side, I have to get my constant over to the left, so subtract 104 from both sides. 36 minus 104 is negative 68. So negative 68 equals 20y. And now I want to make the coefficient of the variable 1, so I'll divide by 20 on both sides. So this fraction is not going to simplify into an integer. When I divide 68 by 20, it's not a whole number. but I can go ahead and simplify that fraction. It is negative, so I'll still have a negative. 68 and 20 are both divisible by 4. When I divide 68 by 4, I have 17. And when I divide 20 by 4, I have 5. So negative 17/5 is equal to y. I'll leave this check to you, but you could certainly take this value, negative 17/5, plug it in for y. You could use a calculator even if you wanted to. Go through the order of operations, 7 times that value, then subtract 1, then multiply by negative 2, add 4 times 6, write down whatever answer you get. Then do the same thing on the other side. Negative 8 times negative 17 over 5, add the 13, and then multiply that by 8, and you should have the same result as what you got on the left-hand side of the equation.